A group of 15 friends visit an adventure park. The group consists of 4 families, Mr. and Mrs. Kenny and their 4 children. So we have here 2 adults in this family and 4 children. Second, Mr. and Mrs. Lizo and their 3. So we have 2 adults and 3 members for the children. Mrs. Martin and her child, so 1 adult and 1 child. Mr. and Mrs. Nuts, so will be 2 adults and 0 for children. The group travel to the park in 3 cars. We have 1 car, 2, and 3 cars. Travel in 3 cars. 1 containing 6 people. This is 6 people. And 1 containing 5. And 1 containing 4. So the total will be 15 members. The cars are driven by Mr. Lizo, and Mrs. Martin, and Mrs. Nuts, Mr. Nuts. Okay. Now, how many left after select the drivers, like 1, 2, 3, how many left from the 15 will be 12 left? How to distribute these 12? In how many different ways can the remaining 12 members of the group be divided between the 3 cars? For the first one, it's 12. We'll select how many to complete the car. It's already 1 outside. 3 outside. For the first one, how many members are needed to complete the group of 6? It's 5. So when we take 12 C5, so how many left? 7. So now 7. How to complete the group of 5? Still 4 needed. So 7 C4 times. When we select a 4 from 7, 3 left, but I need here 3, it will be 3 C3, which exactly is equal to 1. So how to distribute into 3 groups like this? So 12 C5 multiplied 7 C4 multiplied 3 C3. Answer is 27720. The group entered the park by walking through a gate one at a time. In how many different order can be 15 friends go through the gate if Mr. Lizo go first and each family stays together? Let's first arrange Mr. Lizo. So how many left of the members? There are 14, sorry. But each family together, we have 4 families. We have to rearrange Lizo at the beginning, Lizo family at the beginning, firstly. So will not rearrange this family in between. So Lizo, which family? The second one. Lizo, how many members left? It's 4. Will arrange in between firstly. So how will be here 4 factorial. Now, there are 3 families. In how many ways we can rearrange the 3 randomly? It's a 3 factorial. But we'll rearrange each family in between. The first family, there are 6. So after rearrange, we'll rearrange it 6 factorial. Second family, these are done. Third one is there are 2, will be 2 factorial. And this family, it's also 2 factorial. So find the product of 4 factorial, 3 factorial, 6 factorial, will multiply in between. multiply, 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 and multiply. So 4 factorial multiplied by 6 factorial multiplied by 2 factorial multiplied by 2 factorial, and don't forget to multiply by 3 factorial. So the answer will be 4, 1, 4, 2, sorry, 7 to 0. 7 to 0. Part C. In the park, the group enter competition which requires a team of 4 adults and 3 children. Before we started to read, we have how many adults? 2 plus 2 plus 1 plus 2. 2, 2, 2 will be 7 and 8. 7 adults. We have here 7 and 8. For 7 adults and 8 children. We'll select 4 from the adults and 3 from the children. If there is no restriction, we'll write 7C4 times AC3. In how many ways can the team be chosen from the group of 15 so that the 3 children are all from different families? 4 different families. So I will write here for the 8 children, will distribute from the first family, there are 4. Second family, how many children? There are 3, 1, and 0. We'll take 3 children, 1 from each family, so will be 4C1, 3C1, and 1C1. What about the adults? There is no restriction for the adults, and we'll select 4, so will be 7C4. Find the product of 7C4 times 4C1 times 3C1. 7C4 for adults, there is no restriction. 4C1, 3C1. We cannot, we can remove 1C1, it's correct because it's 1, but it's better to know why it's 4, 2, 0. Part D, in how many ways can the team be chosen? If you look at the information given in this part, still we'll select 4 adults and 3 children from the group. In how many ways can the team be chosen so that at least one of the Mr. Kenny or Mr. Lizo is included? So firstly, there is no restriction for the adults and for the children in this part. It's written 3 children, and there is no restriction about the children. So firstly, I will write 8C3. Now it's done for the children. What about the 4 adults out of 7? There are 4 adults out of 7. It's written at least one of them. So the first case, if Mr. Kenny will be. Second case, only. This is only. If Mr. Lizo will be on the group only. Maybe both Mr. Kenny and Mr. Lizo will be in the group. So the first case, Mr. Kenny will be on the group. So firstly, 8C3. Then multiplied by. How many left to form a group if Mr. Kenny will be, but Mr. Lizo is not? So I have to remove Lizo from our selection. So Kenny, there are 7 adults, there are 7, but we'll keep 1 outside of our selection and we'll take Kenny. So how many left from these 7? There are 5 left. We'll select a group of 4. So will be a group of 3, 5C3. So the group now is 4 adults, Kenny, and there are 3 more. If Mr. Lizo only, by the same way, we'll remove Kenny outside and we'll keep Lizo will be in the group. So will be 8C3 times 5C3. So we can take one case multiplied by 2. But remember, each time we write here, firstly, same, 83, this is for the adults, for the children. If Mr. Kinney and Lizzo will be in the group both, so now we have to complete the group will be 5C2. In between multiply, find the first case, find the second case, find the third case, then add. For the first case, it's 5C3 multiplied by 8C3, it's 560, 560. Also for the second case, it's the same, 460. For the third one, 8C3 times 5C2, it's also 560. We'll add all these cases, so the answer will be 1, 6, 8, and 0. That's it.